We've got an object of mass 3 kilograms moving under this constant force. We know the force is 9I plus 15J, okay? And in part A, then they want us to determine the velocity vector. Now, if we know the force, I can work out the acceleration, can't I? Because of Newton's second law, okay? So using Newton's second law, we've got ma is what the force is, and of course then because m is 3. Okay, I can then just divide by 3 and I get 3I plus 5J for the acceleration. Now to get the velocity vector, you just need to remember that acceleration is the rate of change of velocity, so dv by dt. Okay, so we've got this here and we just need to integrate them by separating the variables. Okay. So integral there, well this is 1 there, so you get v, 3ti here plus 5tj there. And then don't forget then a constant of integration. Okay, so then with a constant of integration, we need to work that out. And they do say in the question there, when t is 0, it's got a velocity vector of minus 2i plus 7j. So when t equals 0, v will equal to minus 2i plus 7j. So you plug it in there, so you could see then that minus 2i plus 7j will equal to c, okay? So therefore, v is equal to 3t minus 2i plus then 5t plus 7j, okay? So it says then in part B to calculate the distance. Okay, when calculate the distance when t is 2. So now we need to integrate again, don't we? Because we need to appreciate that v is just rate of change of r. Okay, so if I rewrite that as dr by dt, so then separate the variables. Okay, so I get r equals to 3t squared over 2 minus 2t I plus then 5t squared over 2 plus 7t j plus then my constant, so we call this constant d because I'm integrating again, so a different constant, call it different to c from before. So then we're told when t is 0, r is 6i minus 9j. So that's what d will equal to, okay? Effectively, because t is 0, that's what r is. So then we say, therefore, r is equal to 3t squared over 2 minus 2t I plus 5t squared over 2 plus 7t j plus then 6i minus 9j. Okay, and we can group them together as well, can't we? All right, so we get that's what we get there. So then, when t is 0, we've done that. We've got the position vector. So now they want to know what the distance is when t is 2. So when t is 2, we just sub it in, right? So we just sub it into that there when t is 2. So r will equal to, okay, so put it in there. So if we work that out there, we get 8i here. And if I work this out here using a calculator, of course, we get 15j there. Now we want the distance, right? So to get the distance, remember, okay, to get the distance, we need to use Pythagoras, okay? So Pythagoras then, because that's the displacement, the distance then, we'll use the Pythagoras. So we've got 8 squared plus 15 squared. Work that out, comes out to be 17 exactly.